Hi guys, here with your science lesson for today. So we looked at conductivity and insulation last lesson. So we're going to have a look at trying to understand what an insulator is. So we were looking at how quickly something conducted heat away in our last science lesson. So we're going to try and keep the heat in this time, keep things nice and toasty warm. So just like last lesson, we need to know what conduct and insulate means. So hopefully we remember that if something conducts, it makes it really easy for it to move along it. So if we think about heat, if it conducts heat well, the heat moves easily through it. If we're insulating, we're stopping the heat traveling through. So we're going to make our predictions again. We're going to use our knowledge. So we're going to use some of the ideas that we did in our last lesson. We're going to use them to help us make our predictions. And we're going to investigate which materials make the most efficient thermal insulators. So last time your task was to test the insulation properties of different containers. Now looking on Tapestry, we had lots of wonderful ideas. We had mugs, we had Tupperware pots, we had thermos flasks. We've had lots of different things tested and lots of really good results. So there we go. Some of the ideas that I thought of that we could test. So we've got a mug, a glass, a pan, and a Tupperware pot. So we've done well with these. We've identified which ones allow the heat to travel out quickest. So they're the best conductors. So hopefully you were very careful putting the hot water into each one. You made sure you had an adult just in case something went wrong, or you maybe got your adult to help you all the way through. Whichever way you did it, so long as you've done it safely and we don't have any extra blisters, that's absolutely brilliant. So we waited to see which material kept the water the hottest after 10 minutes. I know some of you were able to use a thermometer, which was brilliant because you get some really accurate results that way. Some of the images I've seen of you testing the things using the back of your hand, I'm really pleased to see you doing that because, as I said in our last session, if we use the back of our hand, we're a lot less likely to burn ourselves because we can move our hand away a lot quicker than we would do if we were the other way around, because sometimes the urge is when you've got your hand that way around is to grab something because that's what the muscles want to do. So by using the back of your hand, you're keeping yourself safer as well. So you know which out of your sample was the best insulator. So, or which one was best kept the water warm while we were doing this experiment. So, well, what great scientists, but can you make them even better? So we've got Grumpy here setting us a challenge. If your bodies are cold, it means that heat's escaping. And this has certainly been true the last few days when we had the snow. We were out building snowmen, having snowball fights. It's amazing how quickly you can get cold. So you need to keep the heat in with an insulating material. So we can have man-made materials like these lovely coats that you can see the people wearing here. You can have natural materials as well. So the Eskimos use reindeer furs. They all do the same job. They keep the heat in and close to your body to keep you warm. So as a note here, lots of thinner layers work better than one big thick layer. So what your body heat's doing is the air that gets trapped between each layer keeps you warm. So you warm up the air between each layer, and the more layers you have, the longer it's going to take for that heat to escape from your layers of clothes. So we use this idea in lots of ways. We wrap hot water tanks. So somewhere in your house, you might find a big tank which has got wrapped around it what looks like a towel with a bin bag around it. It's the best way I can describe it. What it does, it keeps the water in there hot. It stops the heat escaping. And quite often you use it as an airing cupboard. So you've got to keep your towels in there. So when you get out of the shower, you can reach in if you need a clean towel and it comes out nice and warm and soft and fluffy. Certainly I know that that's what I do with mine. It also saves energy. So you're not having to continually heat that water up. It gets hot and it stays hot because it's wrapped in insulation. It stops the heat escaping from that tank. And ultimately that saves your parents some money. So windows are double glazed. So you have a layer of air between the windows. So if you go and look at your windows, you should be able to see, as we've got in our image here, a sheet of glass on the inside, and you'll see a gap. And then you'll see another sheet of glass for the outside. That gap gets heated up. So the heat that your heating system creates warms up that gap, and it slows down the transfer of heat from your house outside. I know from experience that a window that's only got one piece of glass in it, you get much colder much more quickly. So again, this is saving energy and it's saving money. So even simple things like draft excluders or just closing a door, it stops the heat from escaping from a room. So it might be that if you've gone out for the day and you've left a room shut, the door shut in there, and the heat's been on, you'll come in and that room will feel much warmer than the rest of the house because the heat's got trapped in that room. So again, the door is providing some insulation. So this, by keeping the heat from escaping, you're saving energy again, and of course, saving money. So if we carry on with this idea, if you go around, keep all the doors shut, keep all the windows closed, and make sure you're all wrapped up really warm, you can save lots of money on your heating. So we can make our containers better with thermal insulators. So again, this is a heat experiment. So we're going to be using hot water. It's really important that you have an adult help you setting it up just in case something does go wrong. If something does go wrong, what you need to do is go to the tap in the kitchen sink or the bathroom sink, depending on where you're doing your experiment, turn the cold tap on, get whatever you've splashed the hot water on and keep it under there for as long as you can. 10 minutes is ideal. Then that way it'll prevent any more damage being caused. So it might be just splash off onto your hand, go and get it under that cold tap, take all the heat out of it. You'll have a really cold hand afterwards, but you won't have a burn. So if you do splash water on yourself, make sure cold water on top, it'll cool it all down and it'll stop any damage being done. So your task, choose one of your containers that you have a few of. So if you've used a mug, for example, you've got 4 mugs that are roughly the same. If you've got 4 that are exactly the same mug from the same shop, that are the same design, that would be brilliant. Don't worry if you don't, just make sure they're a similar material. Using different soft materials for each one, wrap the container up. So you could wrap a clean woolly sock around one of the mugs. I don't suggest using a dirty one. It's going to get warm and it's not going to smell very good. Wrap some foil around another mug, maybe try a t-shirt for another one and see what else you've got. So wrap them up to keep the heat in. Carefully, and I can't stress this enough, carefully pour hot water into each container so it's about half full. We don't want to go all the way to the top because if we bump it while we're doing our test, we might burn ourselves and then we're back to the sink to run our hand under the cold water and off we go again. So about half full. Predict. So we're going to make a prediction again. Which jacket will keep the water warm for longest? So write it down. I predict that the sock will keep the water warm for longest. That's the sentence you need to use. And then just like last time, after about 10 minutes, go back, carefully remove the wrappings, make sure you don't knock the cup over. And as we did before, back of the hand, remember, feel the outside of the containers. Which one has kept the water hottest? So this is why it's important we have the same material this time round. So we're not looking at what material keeps the water inside it the warmest. We're looking for the material that goes round the cup or the glass, whatever we're using, and keeps it warmest. So if you've got a thermometer, you could use one of those. I've seen some of you have done it with a thermometer. It gives you a different data set and you can more accurately see which one has kept it warmest for longest. If you don't have a thermometer, please don't worry. The back of your hand will do fine and you can rank them as you did last time. So I've given away what we're going to do for the next step. We're going to rank the materials from the best insulator, so the one that's the hottest, to the worst insulator, so the one that had cooled the most. Just on that point, what you could do is use one extra thing, if you have one, and have one with no insulation at all, and see if you can tell the difference between the one that's had no extra insulation around it compared to the other 4 that you've tested. Worth a try just to see whether one of your insulators has actually a conductor and has taken away more heat than it's kept in. Just a little interesting development on your investigation that you could do if you think, oh, I'm not really sure whether that one's made it colder because it's actually a better conductor, or there's something else going on. Create a clear table of your results. So exactly the same as we did last time. You're going to draw your table with your object, what it's made of, what your insulator was made of, and your insulator is what you're going to rank this time as to what was the best and what was the worst. What you'll also need to do is write up whether your prediction was correct. So if you've got your prediction completely wrong, don't worry, that's why we do investigations. We're experimenting, we're looking at what works best. If you have got your prediction wrong, have a go at working out why your prediction was wrong. What properties did the material that didn't turn out to be the best have that the one that was best didn't have, or vice versa? So what was the one that was the best insulator? What properties did it have that the one that the worst insulator didn't have? Can you maybe make some comparisons with some of the materials? Good luck. I look forward to seeing these on Tapestry. And I'm going to say it one last time. Please be careful. You are using hot water for this experiment. We don't want complaints that you've burnt yourselves. If you do splash water on yourself, 10 minutes under the cold tap, and it should stop the burns. Good luck. I look forward to seeing your work on Tapestry. Stay safe, and we'll see you soon.